Okay, this is unit number 3, video number 11, resonance and charges. We're going to look at a concept called resonance. The best way to show resonance is to give an example. So I'm going to start with SO2, sulfur dioxide. SO2, go through and do the Lewis structure. Sulfur is the least electronegative element, so it's getting in the middle. We know oxygen rarely is in the middle. So S, like this. So now, I've got to figure out the number of valence electrons. Well, sulfur is in the same column as oxygen. So they each have 6. 6 times 3 is 18. So I have 18 electrons to draw my picture. 4 of those are already assigned to bonds. So I have 14 electrons available to complete the octet. Now I want to assign the octet. This oxygen has 2 and wants 6 more. This sulfur has 4 and wants 4 more. That's 10. This oxygen has 2 and wants 6 more, so that's 16. So we need 16. When we need more than we have available, we're going to add a bond. But you look at this compound here and you can say, well, it's equally likely to be in both places. That's what we call resonance. So in reality, or what we're going to do, is draw the double bond here, and then put a double arrow, and draw it again with the double bond in the other position. A little pair up there. The term resonance comes from an instrument string resonating in 2 positions. Okay, you've all seen that. So the thought initially was that this double bond is actually flipping back and forth. It isn't. It's equally shared across both bonds. So it's basically 1.5 bond here, 1.5 bond here. How do we know that? Bond lengths are identical, bond energies are identical. So both sulfur-oxygen bonds are exactly the same by all experimental evidence. Okay? So that tells us that there's no localized bond here. We say the electrons are delocalized. They're equally shared, this pair of electrons between both sulfur-oxygen bonds. So that's an example of resonance. Another example would be nitride, and this introduces the concept of how are we going to handle a charge in a Lewis structure. Well, all we're going to do is add or take away from the total valence electrons. Don't do anything else with that charge. Okay? So here we're going to have the nitrogen in the center, N, O, O, and I go through and calculate my number of valence electrons. I've got 6 plus 6 is 12 plus 5 is 17, but this tells me there's an extra electron. So I have 18 electrons. You can quickly see, same form, same number of electrons. We're going to subtract 4. 14 is going to be our available. We're going to need 2, 4, 6. We're going to need 4 here. That's 10. And we're going to need 2, 4, 6. That's 16. So we need 16, the difference is 2, we're going to add a bond. Equally likely positions to add that bond. We can add it here. Or we could add it here. That's the indicator to us that there's resonance. Now normally if you have a charge, you want to draw your Lewis structure showing that charge like this, because there's an NO2 and there's an NO2 minus. Both exist. So we want to differentiate that this structure is for the negatively charged ion.